Hi, I'm Nina Zakharenko, and welcome to More Fun with CircuitPython, IoT, wearables, and more. A little bit about who I am. I currently work at Microsoft as a Python developer advocate, and my focus is to make Azure and VS Code better to use for Python developers everywhere. I've written software for a long time at companies like Meetup, Reddit, and HBO, and I've worked on a lot of projects, big and small, in a wide variety of organizations. If you'd like to reach out, please follow me on Twitter at NNJA, and occasionally I also live code on Twitch. You can find me at NNJAIO, and my website and blog is at nnja.io. I just wanted to let you know that the slides are available to download, and the URL is on almost every slide. And if you download these slides as a PDF, you can click through the links. There are lots of helpful resources throughout. So, why Python on hardware? You might be wondering. Well, as we know, Python is easy to learn, it's easy to teach, and writing C++ or Arduino isn't necessarily accessible to everyone in quite the same way. And since Python on hardware has become more popular, I've seen the makerspace become a lot more active, more diverse. There are plenty of educational resources, and I feel like it's really leveling the playing field and allowing a lot more people to participate who might not have been able to participate before. Now, this talk is going to go a little bit beyond the basics. 2 years ago at PyCon US, I gave a keynote on how Python on hardware is changing the hardware landscape for the better. So if you want to start with the basics, I recommend that you watch that talk. Well, a very favorite activity of mine is wearable electronics. I love using creativity to figure out how to put LEDs in clothes and jewelry and more with tiny batteries and microcontrollers. You can add interactivity like sensors, screens, some of them even support touch. You can create graphics. You can also connect with Bluetooth. And I'm going to show you a little bit of a demo of that later. You can add sensors, so you can test for measurements like temperature, humidity, light sensors, microphones, all sorts of things. And also, if your device supports internet connectivity, you can use the whole Internet of Things landscape. So you can use data from APIs, you can log data from sensor readings over time, you can even send remote commands to your device. You'll really need to consider the needs of your project when you choose a device and you choose your components. Is it for IoT? Well, then it's going to need Wi-Fi. Do you need sensors? Are you going to be measuring anything? Are those sensors going to be on board, so on the device itself, or are you going to have to purchase those components separately? You might need to consider the size. For example, for wearables, you might need smaller components, smaller batteries, flexible materials. Or if you just want to run straight Python, you might consider a Raspberry Pi instead of working with a variant like CircuitPython or MicroPython that's a variant for microcontrollers. And lastly, you're going to want to think about, are you comfortable with soldering or not? So as you advance in your Python journey, your Python on hardware journey, you're going to have to learn a few other concepts and a few other topics. You're going to need to know a little bit about electronics. Honestly, it really helps to have understanding of some of the basic concepts. You don't need to have a 4-year degree in this topic to be successful at it. I would say that SparkFun has some really good resources, and some of the things that you're going to want to learn about are those basic concepts. You're going to want to learn about units of measurement. You're going to want to learn about basic circuits and things like a voltage, current, resistance, and Ohm's law as well. There are a ton of free resources and tables available online, and a great high-level overview is from SparkFun's Engineering Essentials. So let's talk a little bit about circuit basics. On the left-hand side, you have a proper circuit. So there's a power source, there's a resistor, there's an LED, and using a voltage source, we can then add a load to the circuit. And based on how the circuit is shown on the left-hand side, the LED is going to light up. So it's exactly what we want. In the middle is a broken circuit. So if one of those components is not connected to each other, there's no way for the electricity to flow, and so your LED is going to be off, nothing's going to happen. Let's say that you end up with a short circuit. Short circuit means there's infinite current and there's nothing in the way to power, and in that case you might end up with too much power going through the circuit, and it might cause a short or worse. Now, a great way to conceptualize this is an app that I found called iCircuit 3D. It costs about 15 bucks. Unfortunately, it's only available for iPhone or iPad, and it features a lot of different components that you can drag around, you can connect them virtually, and you can simulate a circuit. There are a bunch of different templates, and this particular template is just 2 batteries, a resistor, and an LED. You can click on the components to get more information about them. So this is a working circuit, but as soon as I delete that connection from the resistor to the negative side of the battery, our circuit turns off. Now, let's say I zoom in and I delete the resistor. The resistor is going to prevent too much of a current hitting this LED. And when I reconnect that LED directly to the batteries without the resistor, we'll see that there's too much current and there's a little animation of the LED smoking. So this is a really great way, like if you're a visual learner like I am, to conceptualize some of these topics. Next up, we have breadboards, and they're named breadboards because back in the day, the way that people would mock up their circuits would be with a board that they put bread on, like a cutting board, and they would hammer nails into it and like wire stuff directly to it. So it's retained its historical name, but not necessarily the same shape. So a breadboard is a no solder way to connect components. You might not be comfortable with soldering, you might not own a soldering iron, you might not want to invest in one just yet, and if that's the case, using breadboards is a great option. The components that are used with breadboards, they need leads or legs to be inserted into them, and then using jumper wires, you can then connect different components on your breadboard to each other just by using these wires. And this is awesome because it allows you to reuse components, it allows you to prototype and test the circuit, and if you need components that have leads, occasionally you can buy those pre-attached. Like I know that Adafruit sells some versions of their microcontrollers with soldered on, you might hear them called headers as well. So they have options for both. So all you need to do is hook up a power source to your breadboard, and you'll see the red and blue rails on the sides. Those provide power and ground. And this is also kind of a great way to have semi-permanent projects. There's nothing stopping you from putting all these components together and using them on a breadboard. There's also an app called Fritzing that you can use to diagram some of these things conceptually, and then Fritzing has libraries that contain a lot of different components that you might use. Now, soldering. I want to say that soldering is not hard, but making clean connections does take patience. There are some safety precautions that you have to follow. The tip of a soldering iron is very hot. There are safety considerations in leaded versus unleaded solder. You definitely want to wear eye protection when you're soldering because little pieces of molten solder might come flying off, and you definitely don't want to get that into your eye. And then you also don't want to breathe the fumes, so you want to make sure that you have good ventilation. So All of these kind of tend to, I think, scare folks away from soldering. But really, if you're able to have someone teach you who already knows how, or when it's safe to do so, you can take a class in a makerspace. You'll see that as long as you're following all the safety precautions, it's actually really, really straightforward. There are two resources that I like. One is the Soldering is Free comic book, which is on the right-hand side here. It's free and it's illustrated. It's a very great in-depth guide. And then there's also the Adafruit in-depth guide, as well as videos that they've published. And soldering is going to allow you to make more permanent connections between components. Now, how do you add interactivity to your project? Because interactivity is what makes your project fun. Well, there are lots of different ways to do it. You can add buttons, switches, knobs like potentiometers. You can add sensors like for temperature, air quality, sound, and a lot more. I do want to say that if you buy a device or a microcontroller that has sensors on board, chances are they're not going to be quite as accurate as specialty sensors that you can buy separately and then either solder them to your microcontroller or use a breadboard. For example, there's a sensor on the there's a sensor on the Adafruit Clue board for temperature, but because the component itself runs very hot, the temperature that's detected tends to be a few degrees higher than the ambient air in the room. And you might want to add connectivity. So see if your board is Wi-Fi enabled. You can connect to the internet. You can log data. You can hit APIs. Bluetooth is going to allow two components to talk to each other via Bluetooth Low Energy. So you can control a microcontroller from your phone or your computer, or even have two of them talk to each other. There's also radio for situations where you might not have internet, but you want devices to communicate over a longer distance. And you can also, depending on what connectivity you have, use things like API calls or even triggers. If your device is online, you maybe can trigger different activities depending on sensor readings. So I made a social battery LED lanyard, and this was for conferences, so before COVID started. And the goal of this project was to select a social energy or battery level from a touchscreen menu on a badge that I'm wearing. And then the LEDs on that badge are going to change color depending on the selection. So let's take a look at that. This is created with a PyPortal Pint, as well as some components that allow me to use this device with a battery. So let's say that my social battery is green, or let's see, let's go back here. It's a bit hard to use this upside down. Really hard to use this upside down. There we go. Let's say my social battery is full. So that means that I'm not tired, I'm ready to talk. Once I select full, you should see a green LEDs lighting up on this lanyard here. There are also states for if my social battery is empty, maybe I'm getting tired, or if my social battery is low, maybe I'm getting tired, or if my social battery is empty and I'm really tired and I don't want to talk to anyone, that will flash these LEDs on the lanyard to be red. Now, I don't expect to be going to any conferences anytime soon, but I think it would be fun to repurpose this project to, for example, indicate how open I am to other people walking up to me on the street, or add events. Maybe I want people to keep their distance, and I can indicate that with red LEDs, or maybe I'm okay with folks coming up to chat with me. So this was a fun project, and I definitely think there are a lot of interesting uses and implications. So let's take a look at the code for this project, or rather some of it. The whole code is on GitHub. So let's take a look at the code for this project, or some of the code, because the whole code base is available on GitHub. Now, the first thing that you kind of have to know is this is always running in a loop. And I'm listening. This is the code that kind of listens for touches and then takes an action depending on what was pressed. So I'm checking to see if there was a touch. And if there was, I'm going to go through every button on that main screen. And I'm going to check to see if that button contains the X and Y coordinate of the touch. Then, if that button is in a group that has a background associated, the status backgrounds are the ones that display what the social battery status is, then it's going to hide what was visible in the, or actually, I guess it's in reverse. It's a little bit confusing. It's going to show a back button. It's going to hide everything that was on the main screen and then show that correct background and show a back button so that I can then toggle back and forth in between the two states. And the code for this is available at git.io/socialbattery. The other project that I wanted to show off, and you might have noticed me wearing it, is this LED jacket. And this jacket is based on a design by Sophie Wong. And you can purchase her book on Wearables for just a few bucks, or download a free PDF. These hexagons are 3D printed on fabric, which is awesome. So I wanted to remix her design. And my goal was to be able to control the jacket via Bluetooth. And in this case, I can actually control the jacket from my phone. So I can change colors, patterns, and a lot more from my phone or my watch. And something else that I really like is that the controller and the battery for this fit in a very, very small package. So I'm just going to disconnect it for a moment and show it to you. This is the, I believe, the NRF52 feather. And then it's just in this 3D printed case. All the files for 3D printing are available to download for free. There's a convenient on-off switch right here. And then the battery is contained in this smaller box down here. And all these components snap together. And I was just able to solder on a JST connector, which then connects to the LEDs in the jacket. So it's very easy for me to take out this little bundle and charge the battery. The way that you would connect to this jacket is with the Bluefruit Connect app that is present in, it's for iPhone, it's for Android. So I'm just going to take a moment to use my phone to connect to this Bluetooth device. And then I'm going to open up the color picker. And once I do that, I'm able to open the Adafruit app on my Apple Watch. And if you can kind of see right here. So now that I've opened up the Bluefruit Connect app on my phone, I'm going to be able to control the colors or send color packets from my Apple Watch right here to my jacket. So let's select this purple color, and you should see my jacket changing. Let's go ahead and select green, and you'll see the jacket changing as well. So this is it's a pretty fun party trick. There are other kinds of controls that you can send. So there's a control pad, and I can use that control pad to change the brightness on the animation, or change the speed that the animation is playing at, or change between different animations, and that's just available here on my phone. So that's a pretty fun project. Let's take a look at some of the code. So this is the code around the Bluetooth connectivity. So what I'm doing here is instantiating some of the components that I need, and then I am sending out an advertisement from the device in my pocket saying that it's ready to be connected to. Once it is connected, I'm going to start an animation sequence, and I'm going to wait for packets from this device. So when a packet comes in, I'm going to check to see, are you a packet that is of type color packet? And if it is, I'm going to grab that color value and use that to change the LEDs. If it's a button packet, for example, if the right button was pressed, I'm going to use that as a trigger to play the next animation. There's a lot of cool projects for IoT stuff, which unfortunately I don't have a lot of time to dive into, but two that are pretty nifty is one, the PyPortal IoT weather station on the left-hand side by Brent Rubel. And the other one is a PyPortal that connects to Azure IoT, and it uses it to monitor your plant's health, and it'll let you know if you need to water your plant. So it tests the temperature, and then it also tests the humidity in the soil using a special type of sensor, and it can let you know how well you're doing at watering your plant over time. So that the library for that was created by coworker Jim Bennett, and I highly recommend checking it out. Now, some resources for continuing on your own journey. I want to say you should definitely follow awesome makers. One of my favorites is Odd J. He recently was on the cover of Make magazine, and he creates like really cool steampunk robots, and he has a companion robot that he keeps on his shoulder. He's a really fun person to follow on Twitter. Becky Stern is an inspiration. Sophie Wong, who created the guide for making this 3D printed LED jacket. Geek Mom Projects is awesome. She's constantly posting new stuff. Stargirl Flowers does a lot of work with CircuitPython and synthesizers. And then the Ruiz brothers do a lot of cool stuff with circuits and 3D printing and fabrication. And there are really just so many other amazing makers. Helen Lay, she makes soft robots that light up and interact. And then Christine Sunu also makes amazing robots that are really fun and interactive. So I highly recommend checking all of these folks out. Deborah, Geek Mom Projects, she did a great talk at PyCascades 2020 recently, where she talked about all of her cool LED projects. So I recommend checking that out on YouTube. She's also the creator of something called a Bright Bag, which is a programmable LED bag. And it supports the microbit and MicroPython, or the Adafruit Clue and CircuitPython. And if you use the Adafruit Clue board, then you can use Bluetooth. And I actually have one of her bags right here that I can show off. There's just a, let's get it turned on. There's just a front panel right here that this board snaps into. And because I'm using the Adafruit Clue for this, I'm then going to connect with Bluetooth, and I will show you how to change the colors on this device. So I'm going to have to disconnect from my jacket and connect to my purse, which is pretty fun, and then select the color picker. So I just changed my jacket, and then I'm going to connect to the purse, and I'm going to use the color picker controller here. It kind of looks like this. And then I'm going to send that same color to the purse, and you'll see that it changes. And now my purse and my jacket match. So a little bit of coordination there. Very fun. For guides and help, I recommend Instructables, SparkFun, Adafruit Learn Guides. The Adafruit Discord is also a great resource. There's the CircuitPython channel that's just amazing. And Hackaday for more advanced projects. Thank you all so much. I'm really glad that you were able to watch my talk. Please download the slides if you're interested in all of the additional links and resources. You can follow me on Twitter at NNJA. You can also check out what's going on at Python at Microsoft at nina.to/ms-PyCon 2021. Have a nice PyCon.